Case study of Hurricane Rita, part of the record-breaking 2005 Atlantic hurricane season. Hurricane Rita is often discussed conjointly with Hurricane Katrina, as they were barely 1 month apart. It formed from a tropical wave off the West African coast, as many tropical superstorms do. However, it initially failed to suffice any convection as it moved westward into the Atlantic. Eventually, it would collide with a cold front from an active system north of Puerto Rico. Here, storm clouds would accumulate and organize into a tropical depression. The mass would then rapidly intensify to become a tropical storm approximately 70 miles off of the Caribbean islands. On 20 September, Rita would be recognized as a hurricane over the Florida Straits before hitting the loop current amongst the Gulf of Mexico. Very warm waters and very weak vertical wind shear allowed for tremendous bursts in wind speed. Hurricane Rita grew from a tropical storm to a powerful Category 5 hurricane in less than 36 hours. Rita would make landfall on the Texas-Louisiana border on September 18th at 2:40 a.m. as a Category 3 hurricane. This before dissipating into the Mississippi River Valley on September 26th. Minimum barometric pressure was measured at 952.3 millibars, a record low for the Gulf Coast at the time. The highest Category 5 wind speed was recorded at 178 miles per hour. The inland storm surge would inundate Louisiana and Alabama with up to 15 feet of total precipitation. Altogether, an estimated 45,000 dwellings were destroyed, with damage costs nearing $18.5 billion. Of the 125 recorded fatalities, only 7 were a direct cause of the hurricane. The rest were a result of severe road conditions such as gridlocking upon evacuation. Many passengers were killed from heat stroke and exhaustion from many days stuck on the road without rest. The video shows Rita's propagation as a result of trade winds carrying the storm northward. In a study conducted by the National Center for Atmospheric Research, a panel of scientists concluded that the Atlantic hurricane season of 2005, in which Rita took place, was influenced by the effects of man's contribution to global warming. Research is primarily focused on the change in oceanic temperatures as a result of increased human activity on land. Between 2004 and 2005, Atlantic water temperatures increased 10 to 20 degrees in some instances. This sudden and drastic change was isolated from natural occurrences such as the warm water band El Nino. A panel of scientists discovered that a 0.8-degree increase in total was measured in the Atlantic coast, this credited to human activity, whilst only a 0.4-degree increase came naturally due to El Nino. During this time in American history, global warming was rarely brought up in the political sector, but the drastic change in weather patterns raised many questions. In a study conducted by the Massachusetts Institute of Technology, researchers recorded that from 1970 until 2005, the number of Category 5 and 4 hurricanes had doubled in the Atlantic region. Additionally, more significant tropical storms had increased from 30 to 40% in frequency in the Gulf Coast region. The NCAR's research demonstrated that some spikes in ocean temperatures can be isolated and are not occurring naturally because of El Nino. Though the discrepancy is minute, it is still clear that the convection rate in the atmosphere is increasing as a result of industrialization, leading to the formation of storm clouds and extreme weather scenarios. As a result of this Atlantic hurricane season, the issue was given more attention than it ever had before. This led to the establishment of many international workshops to discuss the significance of climate change. Models developed by these workshops concluded that the Category 3 and lower hurricanes would decrease, whilst Category 4 and higher hurricanes would increase. A likely cause for this would be an increase in vertical wind shear, contradicted by warmer ocean temperatures. Although it is not yet 100% clear whether or not global warming was responsible for these events, the effect of global warming is not going to be unnoticed. As more extreme weather events occur, scientists are paying closer attention to the role of man's contribution to extreme weather. When it comes to preparedness for extreme weather events, one must decide to stay or evacuate in a timely manner. The fact of the matter is, catastrophe can occur both ways, as seen with Hurricane Rita. The best way to prepare for a disaster such as a hurricane is to adapt the infrastructure and local architecture such that it can withstand Mother Nature. Coastal cities contribute 46% of America's GDP, and the population of hurricane-prone counties is increasing by 160 people per square mile from 1980 to 2017. Reports predict rising costs for hurricane damage and an increase in storm intensity in the coming years. Disaster safety is more crucial than ever. Advancements in construction technology have produced building types and techniques and materials that are being codified by law and implemented to better fortify our structures against winds, flying debris, and flooding from rain. Structural prototypes advocate for a conical roof design for better overall aerodynamics, oversized truss hangers for fortification, continuous insulation for flood protection, reinforced windows, concrete pilings, and increased foundation height for greater clearance against water. These modifications can be costly, however, but they have been proven to withstand wind speeds of up to Category 4.